All right, so can organic matter addition offset tillage in organic systems? And I do want to mention only my name is up there, but this was an amalgamation. It was a big project funded by USDA for the Organic Transitions Program. And it was myself and Jody Johnson Maynard, who used to be at University of Idaho, but now she's at Georgia. And then Kendall Call, who was a technician at the time, but now she's actually our organic extension specialist for the University of Idaho. And then there were several graduate students, Will Romano and Dan Teneman. And then we also had an entomologist work on this as well. So tillage in organic systems is the way, try and move this, the way that you control weeds. You don't have a toolbox like a conventional farmer does to manage weeds. And you do that with tillage. And in case you aren't familiar with how transitioning to organic works, you have to act like you're organic. You have to reduce your inputs. There's no more synthetic fertilizer. There's no more, you have a lot fewer options for pesticides and herbicides and things like that. There are options. They're just not admittedly, they're just not as effective because of the chemistry that synthetics have. But you transition for 3 years. So you're all in, but you can't sell your product as organic for 3 years. And that's a tough time. Your yields are lower because you're trying to learn how to manage the system differently, and you're not getting the price premium that a fully transitioned organic producer would have. So this grant and this grant program is really meant to provide transitioning farmers with data to help them make decisions. So we had heard from our organic producers, soil health has been having a moment for the last decade. And the soil health principles are one of the main ones is reducing disturbance. So right then, organic producers are feeling the pain, but they also have the ability and are more likely to apply organic amendments such as manure and compost because that's how they get a lot of their fertility value. So organic systems, I said often rely on tillage. They rely on tillage for weed control. And intensive tillage can cause, negative impacts to soil health effects. We've seen this over and over again. And so it's because I clicked around. There we go. So what we did is we did this study where I'll have a map of it in a minute, but we looked at tillage intensity versus organic amendment amount, and we simplified it. So we decided on compost because we did it in North and South Idaho, and I have a map of that in a minute. But Southern Idaho, as Mario just shared, we have a lot of dairy manure. Actually, my partner up north had to go to the hardware store and buy compost because it's just not as available. And we were trying to replicate it north and south. So we know that compost additions increase stable aggregates, increase organic matter, and boost soil biology. We also decided for that transition period, because Southern Idaho especially has a lot of dairy, and it's pretty common to use alfalfa as your first 3 years as a tool. It's a perennial ground cover. You can sell it to a non-organic dairy. And if you're not purchasing Roundup Ready seed, which you cannot in an organic system, organic or alfalfa seed is actually quite a bit cheaper because you're not paying for the technology that went in to be Roundup Ready. You still have to get that alfalfa established, but it's essentially a perennial cover that the idea or the hope is that it'll choke out weeds and kind of help deal with your weed problem. The issue then comes with terminating that perennial. So initially this project was going to be for 3 years. We had issues getting that alfalfa established at one of our sites. So we moved it, we got a no-cost extension and did 4 years, which ended up being a really big benefit, I think. So the project goals of the grant itself were to facilitate the development of resilient, certified organic farming systems in the inland Pacific Northwest. And we wanted to provide transitioning farmers with strategies and information on soil health and while maintaining their production and economic value, and then assess a whole bunch of soil health metrics. And I'm actually only going to go through 2 metrics and some yield data, but we did a lot, including earthworm measurements, because Jody Johnson Maynard was an earthworm specialist. I didn't know that such things existed. I also didn't know how many species of earthworms there are. It was pretty cool. I am nowhere near an expert, but I like to nerd out about it now. So the 2 site locations, you've heard a lot about Southern Idaho. So we're in this region here. And this is where I am located in Twin Falls County. So I had 2 sites in Twin Falls County. One I call Kimberly and one I call Twin Falls. I'm going to do Southern Idaho first. It's irrigated because we only get 8 inches of precip a year. And most of that is in the form of snowfall that we don't actually use for crops. And silt loam soil, they were actually both silt loam soils. Ours had the added, addition of it's highly calcareous. So we have chalk soil. It's got a lot of natural lime in it, which just makes it really challenging. I'm happy to complain about them all day if anyone wants to know what it's like. And our traditional rotation that producers do, not organic producers per se, but producers, we have barley, potato, corn, silage, alfalfa. And the organic producers in Southern Idaho tend to follow those bigger crops. They're doing organic potato production. There's a market for that. There are organic dairies, so they are providing feed for them. In Northern Idaho, which is where our campus is all the way up in the Panhandle. Happy to discuss with people why it's located up there. But it's rain fed, so 27 inches a year. And Midwesterners are probably thinking, well, that's not really that much rain. And we call it rain fed for a reason. It's traditionally wheat. It's a lot of wheat that's grown in Northern Idaho because it's enough rain that you don't need irrigation, but definitely not enough for much else. The organic producers in Northern Idaho don't tend to grow wheat. Some of them do, but there's a lot of vegetable production and these specialty crops. There is a little bit of alfalfa, there is a little bit of hay, there is a little bit of wheat, but the market is pretty saturated with conventional crops, and there just really isn't the market for organic. They do exist, but it's just a different landscape. And we had 2 sites up there. Actually, I call them Northern Idaho, but one of the sites was technically in technically in Washington in the bordering state, but it was 1 county over. So what did we do? It's a replicated plot experiment, and I have a map on the next slide, but it's important to recognize we didn't actually have a lot of money. The grant wasn't that big, and we were trying to look at a lot of soil health metrics. So within each site, there was no replication. The replication was across sites. So we had 4 replicates because we had 4 sites. And that created some issues with our statistics, which is why you're not going to see any in here. We did work with a statistician, but after the data came back, she had a lot of regrets. So she's fantastic. But I think we talked her into a lot of things. And so we had 3 tillage treatments, which we are going to call high, medium, and low. Very technical. There are some stir values associated with them. I can't tell you them off the top of my head. I know what operations we did. 3 amendment treatments. So the F was what I'm going to call fertilizer, but it's organic fertilizer. In the alfalfa part of the rotation, we use bone meal, which is a phosphorus. It primarily provides phosphorus. And we did that for crop uptake. In the 4th year, we took out the alfalfa and planted spring barley, and we used blood meal, which is a nitrogen product. And for this F, we just provided uptake because our soils were actually very high in phosphorus. And then we kept it at uptake for nitrogen too for a yield goal. We matched that for compost. So for the 1C, that's a single pass or a single rate of compost, it was matched for phosphorus to the F in the alfalfa, and it was matched to nitrogen in the barley. And so it was based on what nutrient was going to be limited for the crop. And then 2C is a double rate of compost. So we just doubled what we put down. And then we did a 3-year cover of alfalfa, and then we took that out and went to barley. In northern Idaho, we actually only had 2 years of alfalfa on one site because they didn't get enough rain and it did not establish. So this is what one of the sites looked like. They were all a little bit different in the orientation because we set it so that we weren't picking up tillage implements across, because one of the sites was on a research farm in North Idaho and one was on a research farm in South Idaho, but then the other one was on a producer farm. So it's one thing to ask our technician to pick up and drop tillage and a manure spreader, but it's something entirely different to ask a producer. Even if you're paying them a little bit of money, they don't have time for that, or the patience, or the equipment. So we just kind of put it across here. This is kind of what that high till just visually looks like versus this is medium and then the low here. This is in northern Idaho. So a lot of it was weeds in this one. So what do we see? So I'm only going to show the barley data because the alfalfa data is just not quite as interesting. And this is kind of the accumulation of all 4 years. So in all of these, it's going to go these 2 sites, GDF and SSF, and I'm going to highlight them like this. Those are northern Idaho. And then these, I couldn't figure out how to take them out. I know how to do it, but I didn't have time. The other ones I'm going to highlight, those are southern Idaho. So we're just going to briefly walk through this. So this is for the organic amendment. So fertilizer, single rate of compost, double rate of compost. So right away, you can see we in southern Idaho had much higher yields. And that's probably because we have irrigation water. Pure and simple. There was no other reason. We planted the exact same variety of barley, and we also did the exact same variety of alfalfa too. But what was interesting is that you could see that yield decreased at this Gray Duck farm, the higher organic matter you got, which was surprised at the compost, the double rate of compost was lower than the single rate of compost. So if you remember, these are within each of these bars, there's 3 plots that accounts for, and then we'll shift it to show it the other way. And in the soil stewards farm, which is what we call it, is pretty even, a little bit of bump in the double rate of compost. In southern Idaho, we really didn't see much different. It was across sites pretty similar, other than our producer site had much lower yield than our research site, which never happens. I think he ran out of water partway through the year, and we did not. So then if we're switching it to look at tillage intensity, so these are the same plots, we're just averaging them differently. For northern Idaho, you can see that there was no yield in that the low intensity tillage, which isn't surprising because they had a lot of trouble terminating their alfalfa. So the alfalfa just continued to exist for the 3rd year or for the 4th year. Medium was a little bit better, and high tillage had the highest yield. We sort of saw that in one of our in our producer farm, but we did not see that on our research farm. It was just a little bit different. So I think overall, we can say that tillage intensity had a bigger impact on yield than that organic matter addition. So then I just briefly, active carbon is a pool of carbon that can be related to microbial activity and soil proteins, and it's what's available to microbes to consume. And you do it with just an extraction method. And just to show that data, again, I'm showing the tillage first, but we're looking at it in the same order. You can see just generally looking at this, northern Idaho had much higher active carbon than we did. That makes sense. They have a lot more organic matter than we do, and it's less calcareous. So they had pretty big differences between their farms. But there really wasn't much difference between tillage intensity and POC. It was a little bit lower as you went to the low tillage, which could have been due to the lack of establishment of the barley in that system. For us, we saw a little bit of difference where on one of our sites, our producer field, it increased as you decreased your tillage. And a little bit, you can kind of see it in the on our research site as well, but it's not as evident. For the fertility in northern Idaho, they did see a difference again at one site, but it was the opposite at the other. We don't know why that happened because you're adding more carbon. So the soil test should have picked up more carbon, and we just didn't see that, which kind of goes to another talk that I give about how these soil health metrics are just can be very frustrating. Like, what are we actually looking at? What are we measuring? And how beyond just how do they change? On our sites, we did see actually a pretty consistent numbers. I guess it kind of increased, but if you just look here to here, this site increased, but it didn't for a single rate. We just did not see the impact of POC. And when you really dive into this data by depth, it was a mess. Like you can't, there's no pattern. There's no rhyme or reason, which is also interesting because I've done a lot of data, I've done a lot of measurements of POC, and it's a really great metric, but it just didn't show up here. Also, I'm not going to go through the Haney test, but we're going to look at a soil health score. So it's like kind of organic, water extractable organic carbon and nitrogen. And it's a score between 2 and 19. We sent this off to a lab. For soil health score, for tillage, disappointingly, not much. Again, and I mean, after 4 years, we did apply a decent amount of compost to this in a low input system. We did see in the lower tillage in our research site that we did have in our sites in Southern Idaho that there was an increase, but there really wasn't much, there really wasn't a lot of impact of tillage. For the carbon amendments, we did see. So when you did the double rate of compost, if you ignore this first site in North Idaho, you can actually see that we did have an increase of soil health score when you added the compost, but really no difference between a single rate and fertilizer. But it's just one metric. And so can we actually say, Haney test versus POC, like which one is the appropriate one to use? So the conclusions, we saw huge differences between North and South Idaho, which is causing a lot of our issues in our data management, or in our assessment. But we also saw big differences between sites in the same region. 4 sites just wasn't enough. But we just didn't have money. And then it was just really mixed results, and it was pretty disappointing from that standpoint. But I didn't show nematode or earthworm data. There is a very significant difference. If you reduce your tillage and you increase your compost, you have buku earthworms and a really great population of beneficial nematodes, which do positively impact nutrient cycling. So just not here.